Okay, so in activity 5, we finally get back to a repeated factor in the denominator. And these do make life a little bit interesting, not just in the fact that we have to set them up in a kind of different way, but also in that when we go to solve for our ABC whatever, it's going to be a little bit trickier. We won't just be able to wipe out everything by choosing the right x values. So let's get started on it before I say too much and mix you up. Okay, so this denominator is already factored. My number one warning to you is you better not be thinking that I need to do x minus 2 and x minus 2 and x minus 2. If I did that, I made those my denominators, and I tried to add all of this together, I absolutely would not get an x minus 2 cubed as my denominator. I'm adding, not multiplying, so those already have an LCD, and it would just be x minus 2. So we need to allow for the third power. There has to have been a third power or you wouldn't get one in your LCD. And then there could be sandwiched into that a second power floating around possibly and a first power floating around possibly. If either of those aren't actually part of it, you'll just get a 0 for its numerator and that'll wipe it out. So that's something that's allowed for when we build this. Okay, so here's the other part that can be weird to people. I've talked about we want this proper fraction set up. So people will look at that x minus 2 cubed and say, okay, well, I should have a quadratic numerator. And the deal is you don't have to do that because the b over x minus 2 squared and the c over x minus 2 are going to do that for you. When we get an LCD, we'd multiply the b over x minus 2 squared by x minus 2 top and bottom, which would give us an x in the top. And then the c over x minus 2 would get multiplied by x minus 2 squared, which gives an x squared on the top as well. So we would end up with quadratic possibility out of this. Okay, so let's start with our clear fractions. So we're going to multiply by the x minus 2 cubed, and we're going to be left with an a, and a b times an x minus 2, and a c times an x minus 2 squared. So our trick will work for us once. If we let x equal 2, on the left-hand side we get 4 minus 12 plus 3. So 7 minus 12 should be negative 5. Yep, making sure I did my arithmetic right. You should too, double check yourself. And then the a is just going to be the a. The b, it gets multiplied by 0, as does the c. So this is actually our answer. A is negative 5. So that one was easy. Gets a little trickier after this because there's no way to wipe out, for example, the a and the c so that it's really easy to get the b, or the a and the b so that it's really easy to get the c. So you have some options. We now know a little bit more. So I'm going to go back and erase. So now we know that this is negative 5. I'm even going to keep track on top because I'm afraid I'm going to lose it as I write this. So we, so far, think we should have a negative 5 over x minus 2 cubed. We're working on the rest. Okay, so two choices. We have up here, I'm trying to think what I want to say. We need to find a b and a c. The x is an unknown, but it's an unknown that can take on any value. So one possibility would just be to arbitrarily choose any two x values. I would leave out the x equals 2 because we've already gotten all the information we can get out of that. But say you choose x equals 3 and x equals 4, and you plug those in, you will get two equations with variable b and variable c in them. We know how to solve 2 by 2 systems, 2 equations, 2 variables. Generally, we would do a substitution, but there's that elimination trick as well, if you remember that. I have a different method that I like, and it works on more than just this situation, so I want to show it to you. Okay, so I'm going to say that I have x squared minus 6x plus 3. I'm going to multiply this all out. So I have a bx minus 2b plus, hold on, I'm going to sneak in a little work so that I don't run out of room. This would be an x squared minus 4x plus 4. So when I multiply that out, I have a cx squared minus 4cx plus 4c. Okay, and then here's the deal. Remember that this has to be an identity. The left side has to be exactly the same as the right side, no matter what. So if that's going to be true, we can look at, for example, there is a single x squared on the left-hand side. On the right-hand side, there's a cx squared. No other x squareds anywhere. If these two sides of the equation are going to be balanced, then this better give me c equals 1 for free. If c does not equal 1, then we do not have the same number of x squareds on both sides, and this is not an identity. So c equals 1 we now have for free, so we can go back up here and say, okay, so c equals 1, which means we're going to have 1 over x minus 2. There we go. And then we also need to work on b, so there's a couple of ways to do that. Let's see, b is hooked to x's and also hooked to constants. But there are 3 terms with constants, so I think I'm going to take the x's. So I could claim that there are negative 6x's on the left, and on the right there's a bx, this should say equals, sorry. There's a bx and a minus 4cx, but we already know that c is 1, so that's a minus 4x. So this is an identity, just like an equation. We know the two sides are equal. Feel free to move things around. So if you wanted to, you could add 4x to both sides, or you can just say by inspection. Okay, so negative 6 has to equal b minus 4, so b better equal negative 2. So at any point when you can stop that, you're fine. When you can stop that, when you can spot that. Okay, so back up here, b is negative 2. So that was negative 2 over x minus 2 squared. Oops, erasing as I write. Okay, so this is our integral. I kind of made a mess on this one. So let's just sneak down to the bottom and say if we need to integrate a negative 5 over x minus 2 cubed, I'm going to be thinking that's an x minus 2 to the negative 3. So I'm going to bump my power up to negative 2. The negative 5 is just going to come along for the ride, and then I need to divide by the new power, which is a negative 2. The middle term is a 1 over x minus 2. So that one's nice because it's a first power. I can just go to that natural log that I know a lot of you always want to go to. And there's no weird chain rule. Derivative of x minus 2 is 1. And then the last one I do want to think about as an x minus 2 to the negative 2. So I'm going to bump that up to the negative first power. X minus 2 to the negative 1. And then I have that negative 2 hanging out in the front. And I have to divide by negative 1. So to clean this all up, and then plus c as well, I would say I have 5 over 2 times x minus 2 squared plus the natural log of the absolute value of x minus 2 plus 2 over x minus 2 plus c. Okay, so it gets a little bit messy, but that multiplying out and comparing coefficients can give you some freebies, kind of like the other method did. So between those two methods, comparing the coefficients on each side and plugging in different x values, you should always be able to solve.